very pleasant morning to one and all present here in this virtual gathering for ATAL FDP on recent trends in artificial neural networks. First of all, I thank ATAL for providing me this opportunity to conduct this FDP on artificial neural networks. Let's start the session with the blessings of our Almighty with a prayer song.
वक्रतुण्ड महाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय
A warm welcome and pleasant morning to our respected excellencies, distinguished chief guests, panel of experts, teams, and our colleagues. Let's respectfully welcome our Honorable Secretary, Mrs. C. Sendamarai Madam, our Honorable Managing Director, Mr. Om Sharavana Sir, and I extend my warm welcome to our Dean, Dr. E.R. Parmeshwari Madam. I would also like to place my warm welcome to our Principal, Dr. C. Priyanka Madam, for encouraging us in executing any of the tasks taken up. My warm welcome to our HOD Madam, Dr. K.P. Sivakami Madam, for her full support in this event to make a successful one. I would also like to place my warm welcome to my colleague, Dr. E. Hari Priya. Without her, this event would not be a successful one. It's a true pleasure for me to welcome the participants of this event for this ATAL sponsored faculty development program. And then a great pleasure lies in me to welcome distinguished dignitaries for the inaugural function today we have with us. A great personality by himself, Dr.N.L.Parthasarathy sir, to be a part of this program and deliver the inaugural function. On behalf of our institution, we welcome you, sir. And finally, I welcome.
Thank you, ma'am.
We all, the teachers, are good in our specialized works. Even though we have to refine ourselves for this, the FDP is providing an opportunity to make us a refinement for this in our teaching, not only in teaching, in the specific area, artificial neural networks. I hope you all will enjoy this 5-day session with the different eminent personalities. Finally, but not least, I welcome all the heads, deans, directories, and various directors of various institutions for this FDP. I welcome you, one and all. On behalf of this organizing committee, I appreciate all the participants who are making a very good cooperation for making this event a successful one. Now I call upon our Now I request our HOD Madam to introduce our chief guest for this FDP. Thank you, one and all. Madam, yes, ma'am. Madam, it's not audible. Madam, unmute your mic, ma'am. Ma'am.
Okay. Yes. A very good morning to all of you. Heartiest welcome to distinguished chief guest of the inaugural session, Dr. N.L.Parthasarathy, scientist from Kalpakkam. A very warm welcome to you, sir.
Thank you,
I
ma'am.
take, thank you, sir. I take this pleasure and opportunity to introduce you to the complete audience. Dear participants, you are also be appreciating the effort that we try to connect the best people in the particular subject who speak and bring about their knowledge. A single initiative that we propose for the fellow faculty members to benefit from his talk. This is a talk which is a faculty oriented talk which can be made use of and benefited by even the students and research scholars. We are today joined with Dr.N.L.Parthasarathy, scientist from Kalpakkam, and then Professor Dr. R. Ravi from Francis Xavier Engineering College, Tirunelveli. Scientist Dr. N.L.Parthasarathy completed his schooling with highest score. He did his basic degree, BE Mechanical Engineering at Madras University. Then MTech Production Technology in MS University during 2001-2002. In Sikkim Manipal University, he did MSc Total Quality Management, and then he did his research PhD Manufacturing Technology in NIT Trichy during 2005 to 2010. In the meantime, he worked as a lecturer in Mookambika College of Engineering, Pudukkottai district from 2002 to 2005. Project Associate in Tata Steel's Consultancy Project in NIT Trichy from 2005 to 2007. And from 2007 to 2010, Young Scientist for DST Fast Track SCRC funded project. From 2010 onwards, working as Scientific Officer in Metal Forming Tribology Program, Material Technology Division, IGCAR Kalpakkam. His innovative works have been published in several international and national journals. He also presented his works in many national and international conferences. He wrote book chapters also. Now, I request such an eminent personality to give the inaugural address to our participants. Thank you.
Yes, sir. The dice is yours, sir. Yes, sir. Yes, sir. Now it's
Am I
on,
audible?
sir.
Yeah, I'm okay. Thank the senior professor for me for giving me an introduction to this audience, and I'm very honored to present this address for the ATAL Tinkering Lab sponsored programs. These days I come across several such programs conducted by different colleges, ranging from engineering to arts and sciences colleges. Several fundings have been given by our central government in order to empower the teaching fraternity as well as the learning fraternity. So I take the privilege of presenting this forthcoming session, which contains around 60 slides. And I assure at the end of the presentation, the teaching faculty or the listeners or the research scholars, they may have a kind of a different kind of ambience and a different kind of perception towards neural networks who wanted to students in the form of their final year projects, or they can add up some sort of favor to their own PhD, which can end up in a very nice publication or a sort of conference work, which can finally will benefit the societal perspective. So I'm just getting into the presentation right now. So the inaugural address is, my scheme of presentation of today's talk is going to be in this particular order. So another next coming days, you are going to be repeatedly being fed about the same definitions of what is artificial network, what is artificial neural network, what is a biological neuron, what are sense. And since I come from a mechanical background, if I don't touch the self-driving cars, it won't be a justice for my own department. So few of the slides which it encompasses on the self-driving cars. And the seventh one is again convolutional neural network where we employ self-driving cars. And the eighth one I find it very, very interesting, a small case study.
Yes, sir. It's audible.
I
But,
think there's a disturbance.
breaking in disturbances.
The fans, I think. Now it may be little more clear. I have switched off the fans.
Yes, sir. It's clear,
Is
sir.
it some sort of clarity is right?
Yes, sir.
Yeah,
The
we are back into this
participants-
inaugural session. Yeah. You just give a instruction to them so that they mute their mics. Yes.
Okay.
Am I audible now?
Yes, sir. You are audible, sir, now.
Yes.
Yes, sir. You can
So, yeah. So I'm coming back to our presentation. So my scheme of presentation, I have narrated it in that 9 steps, and it comprises of some 60-odd slides. At the end of the 60th slide, you may be definitely having some bits and pieces and glimpses of understanding about artificial neural network and its potential applications in different fields. So after the completion of this particular session, you may be supposed to be subjected to same kind of definitions again and again and again. So don't get bored because it's usually when the topic is very generic and some sort of vague kind of even software engineering people, they find the topic is a little hard to teach and a little express in terms of verbal because it's a more of application oriented ones. So you need to have a very fundamental and basic understanding about this. So the presentation goes on this. What is artificial neural network, or what are artificial neural networks? So I just go with learning certain terminologies, and in that way we are demystifying. Demystifying அப்படின்னா mystery அப்படிங்கிறது வந்து ஒரு விஷயம். Demystify அப்படின்னா ஈஸியா புரிய வைக்கிறதுக்காக. அதே மாதிரி ambiguity அப்படின்னா குழப்பம். Disambiguate அப்படின்னா குழப்பங்களை myths ன்னு சொல்றாங்க. Jargon அப்படின்னா the tough terminologies they used in the technology, jargons like legal terminologies லாம் நிறைய Greek, Latin, botanical nomenclatures, chemical nomenclatures லாம் கொஞ்சம் tough terminologies. அது மாதிரி jargons இதுல கொஞ்சம் இருக்கும். synapse, signals, axons, அப்புறம் வந்து weights, அப்புறம் இன்புட்ஸ், அவுட்புட்ஸ், இந்த மாதிரியான டெக்னிக்கல் ரிலேட்டடான டெர்மினாலஜிஸ் அதை மீனிங் புரிஞ்சுட்டாலே யூ மே பி அண்டர்ஸ்டாண்ட். அண்ட் மித்ஸ், சில விதமான மூட நம்பிக்கைகளும் இதுல இருக்கு. இப்படி பண்ணா அப்படி போய் அதை ஈஸியா அச்சீவ் பண்ணிடலாம் அப்படிங்கிற மித்தும் இருக்கு. ஸோ தீஸ் கைண்ட் ஆஃப் இது எல்லாத்தையும் நம்ம இந்த டாப்போட முடியும் போது we should know how we have demystified the AI, artificial intelligence அப்படிங்கிறது எப்படி வந்து வெளியில. So before going to artificial neuron, you should be having a biology. There are 2 types of signals. Dendrites வந்து கலெக்ட் பண்ணது, அந்த சோமாங்கர செல் கலெக்ட் பண்ணிட்டு அந்த டிரான்ஸ்ஃபர் நடக்குது. பிங்க் கலர்ல ஒன் பை ஒன்னா ஒரு காலம் வந்து அடுத்த காலமுக்கு ட்ரான்ஸ்ஃபர் ஆகி goes to axon. Yes, you can see the gradual transmission of the signal. The type of signals, 2 types of signals. Neuron என்ன அப்படின்னு பாத்தீங்கன்னா, there is about 86 billion neurons in the human brain, which is connected about 100,000 number of immediate neighbors. Pocket, it has accessive axillary neuron connection. So I already told there are 2 types of signals we know, one is an electrical signal and secondary signals. And I told already it's a basic element of our nervous system. இதெல்லாமே இப்போ biological பத்தி பேசுறேன். இப்போ மூவ்மெண்ட் ஆஃப் எலக்ட்ரிக் சிக்னல்ஸை நம்ம ஸ்கேன்லயோ இல்ல ஒரு மெத்தடை யூஸ் பண்ணி கண்டுபிடிப்போம். அந்த ஃபிட்ஸ் நம்மளுக்கு எல்லாம் தலையில சின்ன சிஸ்ட் மாதிரி இருக்குது, அதை கண்டுபிடிக்கிறது என்ன பண்ணுவாங்க, EEGன்னு சொல்லி தலையில எடுப்பாங்க. ஹார்ட்டுக்கு எடுத்தா எலக்ட்ரோ கார்டியோ தலையில எடுத்தோம்னா எலக்ட்ரோஎன்செஃபலோகிராம். அது என்ன ஆகும்னா, the signals, electrical signals from neuron to neuron ப்ராப்பரான ஃபேஸ்ல டிரான்ஸ்ஃபர் ஆகி கண்டுபிடிக்கிற டெக்னிக். ஸோ அப்ப எப்படி மூவ் ஆகுது சிக்னல்ஸ் பார்த்தீங்கன்னா, இந்த நியூரான்ஸ் the movement of ions பிளாட்ஃபார்ம் வந்து it is intrinsically transfer of neuron sending signal வந்து presynaptic சொல்றாங்க, receive postsynaptic neuron. Yes, presynaptic அப்படிங்கிற action potential, Post-synaptic அப்படிங்கிறது receiving potential. So again, I am telling these most of the transmitters, neurotransmitters, biology perspective, நம்ம யூஸ் பண்ற. Tell me, ma'am. Tell me.
Sir, are you
Please.
presenting any?
Am I audible?
Yes, sir. You are
Yes.
audible, sir, but your
சொல்லுங்க.
slides are not. Sir, உங்களோட
Slide
slides
move ஆகலையா?
share ஆகல, sir. ஆமாங்க சார், ஸ்லைடு ஷேர் ஆகலைங்க சார். Participants, thanks for your patience. Our chief guest will join within a second.
Madam,
Sir, yes, sir. Yes, sir. Now it's sir, your entire screen is being shared, sir.
Am I audible? ma'am?
Yes, sir. You are now audible, sir.
How are the slides?
Yes, sir. But your entire screen is visible.
How visible, ma'am?
Yes, sir. Now it's visible, sir.
I'm clicking, check that. But I go to the second slide. Is it visible? Second slide?
Yes, sir. Yes, sir.
Yes, ma'am. I'll go in.
Okay, sir. Okay.
So this is my schema presentation. My schema presentation goes in that way, like in the first few, what I will be concentrating, what is about artificial neural network. Second is about comparing the biological neuron with the artificial neuron. Third one is about layout of artificial neural network, machine learning. Fifth one is about application, touching few places where you have potential scope for the application of artificial neural networks. Fifth one, since I come from a mechanical background, I touch the self-driving cars of computer vision technologies. And the same convolutional neural network which is used in the self-driving cars, I'm going to touch bits and pieces in it. Final one, eighth one, I find it's very nice case study, which is giving an insights of touchless display interface with 9.5 hours usual conclusions. So before going to the slide, we are going to see certain things. That is, we are going to demystify customized machine learning. We are going to make it as little crystal clear, and the same disambiguate, குழப்பமான விஷயங்களை கொஞ்சம் குழப்பம் இல்லாம இருக்கிறதுக்கு ட்ரை பண்ணுவோம். And use the usage of jargons and myths. Jargon அப்படிங்கிறது tough terminology. Legal எல்லாம் சொல்லுவாங்க இல்லையா, மோடஸ் ஆப்பரண்டி, இந்த மாதிரி டெர்மினாலஜிஸ் எல்லாம் சொல்லுவாங்க. லைக் கெமிக்கல்ல வந்து ஐயூபிஎஸ்சி, நாமன்கிளேச்சர்ஸ், இந்த மாதிரி டெக்னிக்கலி டஃப் வேர்ட்ஸோட மீனிங்ஸை புரிஞ்சுக்கிறோம். சில மித்ஸையும் நம்ம அன்பஸ் பண்ண போறோம். இப்படிலாம் நினைச்சிட்டு இருந்தோம்னா தப்பு, 100% ரிசல்ட் வரும் ஏன் அப்படின்னு நினைச்சிட்டு இருந்தோம்னா தட் இஸ் நாட் ட்ரூ. சில கன்ஸ்ட்ரைன்ஸ் அதெல்லாத்தையும் பார்க்கிறோம். இதுதான் பயாலஜி நியூரான். இதை பார்த்துட்டு நம்ம ஆர்டிஃபிஷியல் நியூரான் எப்படி இருக்குன்னு பார்க்கலாம். இதுல வந்து பாத்தீங்கன்னா டென்ட்ரைட்ஸ் தான் உங்களுக்கு சிக்னல்ஸை பிக் பண்ற வேலை செய்யுது. உள்ளுக்குள்ள இருக்கிற சோமா இல்ல செல் பாடியில ஒரு நியூக்ளியஸ் இருக்கு. சிக்னல்ஸை கலெக்ட் பண்ணி யூ கேன் see the ping transfer from one column to the next column. It goes to the next axon. இந்த லெஃப்ட் சைட்ல இருந்து ரைட் சைட் போறது ப்ரீ சினாப்டிக், ரிசீவ் பண்றது போஸ்ட் சினாப்டிக். ஸோ நியூரானோட டெஃபினேஷன் இதுதான். Am I audible? Can I go into the same page, ma'am?
Yes, sir.
Yes. So the human brains consist of almost 86 billion neurons, which is connected to 100,000 intermediate neighbors, complex networks. And I have already told neuron interchanges between the signals, which is the nature of electrical signals as well as chemical signals. And neurons is the basic element of our nervous system. So in the EEG சொல்லக்கூடிய the electroencephalogram தலையில, I think few of your friends, உங்களுடைய ரிலேட்டிவ்ஸ் யாருக்காவது ஃபிட்ஸ் இல்லைன்னா திடீர்னு சீசர்ஸ் வந்ததுன்னா தலையை நல்லா ஷாம்பு போட்டு குளிச்சுட்டு வர சொல்லுவாங்க. பிக்கப் பாயிண்ட்ஸ் தலையில வச்சு they take the EEG, electroencephalogram. இந்த electroencephalogramல என்ன பார்ப்பாங்கன்னா அந்த nerve schoolல transmitting of the electrical signals யூனிஃபார்மா இருக்குதா அப்படின்னு பார்ப்பாங்க. அப்போ ஒரு நியூரான்ல இருந்து இன்னொரு நியூரானுக்கு எப்படி அந்த சிக்னல்ஸ் டிரான்ஸ்ஃபார்ம் ஆகுது அப்படின்னா, இட் இஸ் ஆக்டிங் taking place by the movement of ions across the plasma membranes. And the nerves like the plasma membranes movement of ions மூலமா. I have already told sending signal neuron வந்து presynaptic neuron சொல்லுவாங்க. Receiving signal in the neuron is called as postsynaptic neuron. இதுல பாத்தீங்கன்னா தெரியும். This is what they call it as presynaptic. அதாவது சிக்னலை சென்ட் பண்றது ரிசீவ் பண்றதுக்கு பேர் postsynaptic. இது ரெண்டுக்கும் இருக்கிற இன்டர்ஃபேஸ் தான் சினாப்ஸ் அப்படின்னு சொல்றாங்க. ஆக்சுவலா இது ஒரு 12th ஸ்டாண்டர்ட் பயாலஜி கான் அகாடமி அப்படிங்கிறது ஒரு நல்ல ஒரு illustrative diagram இருந்தது. ஸோ ஐ ஜஸ்ட் வாண்டட் டு ஷேர் இட். ஸோ மோஸ்ட் ஆஃப் த இமேஜஸ்ல ஒன்று 2 ஜிஃப் இருக்கும், இந்த கிராஃபிக்ஸ் இன்டர்ஃபேஸ் ஃபார்மேட்னு சொல்ற அனிமேஷன்ஸ். ஏன்னா ஒரு ஸ்லைட்ல ஒரு வீடியோ ஃபீல் கொடுக்கும். ஸோ மோஸ்ட் ஆஃப் த ஸ்லைட்ஸ்ல ஐ ட்ரை டு இன்க்ளூட் இட் இன் த ஃபார்ம் ஆஃப் ஜிஃப் பிகாஸ் I feel picture speaks more louder than the text. I try to avoid the text to the extent possible. As I have told already, neurons வந்து எப்படி கம்யூனிகேட் பண்ணிக்குது. I am speaking about the biological neurons. The communication between them is by electrical and chemical signals. And I have already told synapses is the junction points for electrical and chemical signals. So the electrical signals to pass from neurons to one another என்ன பண்ணும், அந்த synapses மூலமா தான் ஒரு electrical signal அடுத்த நியூரானுக்கு போறதுக்கு ஹெல்ப் பண்ணும். So just a few one slide about the history of the artificial neuron. இது எப்போ வந்தது அப்படின்னு பார்த்தீங்கன்னா, when computers are being just emerging, humans are naturally wired for effortlessly recognized objects. So when you compare computers with human beings, இந்த மாதிரி 2 tough competitors ஒன்னோட ஒன்று கம்பேர் பண்ணும்போது they come across a term called juxtaposition. Juxtapositionங்கிறது எப்போ வருது அப்படின்னா, கம்ப்யூட்டர்ஸ் வந்து ஹியூமனோட ப்ராப்ளம்னு சால்வ் பண்ண முடியுமா? ஹவு கேன் கம்ப்யூட்டர்ஸ் பி பெட்டர் அட் சால்விங் ப்ராப்ளம்ஸ் தட் ஹியூமன்ஸ் ஃபைண்ட் எஃபர்ட்லெஸ்? சாதாரணமா ஹியூமன்ஸ்க்கு எஃபர்ட்லெஸ்ஸா இருக்கிறத என்ன இந்த மாதிரி சிம்பிள் ப்ராப்ளம்ஸை கம்ப்யூட்டர் சால்வ் பண்ண முடியுமா? ஹவு கேன் கம்ப்யூட்டர் சால்வ் சச் ப்ராப்ளம்ஸ் இன் த வே ஆஃப் ஹியூமன் பிரெயின் டஸ்? ஸோ ஹியூமன் பிரெயினை யூஸ் பண்ணி ப்ராப்ளம்ஸை எப்படி பண்றாங்கிற அல்காரிதத்தை கிராக் பண்ணிட்டு அதே சேம் அல்காரிதத்தை வச்சு கம்ப்யூட்டர்ஸ் அந்த ப்ராப்ளம் சால்வ் பண்ற டெக்னாலஜியை ட்ரை பண்ணாங்க. இப்போ 1957ல ஃப்ராங்க் ரோசன்பிளாட் அப்படிங்கிறவர். ஸோ அதுக்கு அவர் நேம் வச்சுக்கிட்டு பெர்செப்ட்ரான் அல்காரிதம் அப்படின்னு சொன்னார். அதுல இருந்து தான் கொஞ்சம் கொஞ்சமா ஆர்டிஃபிஷியல் நியூரான், அப்புறமேல அதுல இருந்து பயாலஜிக்கல், அந்த பயாலஜிக்கல் நியூரானை சிமுலேட் பண்ற மாதிரி வர்ற பெர்செப்ட்ரான் தான் ஆர்டிஃபிஷியல் நியூரல் நெட்வொர்க் அப்படின்னு சொல்றாங்க. ஸோ அதை அப்போ ஹியூமன் நியூரான் சர்வ்ல இருந்து ஆர்டிஃபிஷியல் நியூரான் எந்த விதத்துல இட்ஸ் ரிமார்க்கபிள் அப்படின்னு நம்ம கேட்க தோணுது. What is so remarkable about the artificial neuron? The actual remarkable thing in the artificial neuron is it is actually we will see in the coming slides about what is so remarkable about the artificial neuron. So now I would like to throw a jargon, what is frequently used in the AI history, AI winter periods. Why they call as AI winter is one particular period of times the artificial intelligence lost its job. ஒரு குறிப்பிட்ட கால கட்டத்துல ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ் உடைய இன்ட்ரெஸ்டும் அது வந்து விட தொடங்குது. பாப்புலாரிட்டின்னு பாருங்க, ஒய் ஆக்சிஸ் எடுத்துட்டாங்க, எக்ஸ் ஆக்சிஸ்ல டைம் எடுத்துட்டாங்க. அது எப்போ பாருங்க 1970s 74 வந்து 80 வரைக்கும் அது வந்து பாப்புலாரிட்டி குறைய ஆரம்பிக்குது. செகண்ட் பாத்தீங்கன்னா 87ல இருந்து 93 வரைக்கும் திரும்பி குறைய ஆரம்பிக்குது. இது என்ன சொல்றாங்க, இந்த மாதிரி பாப்புலாரிட்டி குறையறத வந்து ஏஐ விண்டர்னு சொல்றாங்க. விண்டர்ல யூஸ்வலா அனிமல்ஸ் எல்லாம் தூங்க போயிடும் இல்லையா, ஹியூமன் ஆக்டிவிட்டி குறைஞ்சிடும். ஸோ அந்த விண்டர்ங்கிற ஃப்ரேஸை எடுத்துக்கிட்டு அவங்க ஏஐ விண்டர் 1 ஏஐ விண்டர் 2 போட்டுருக்காங்க. இப்போ இது 2 விண்டர் முடிஞ்சிச்சு. இப்போ எல்லாமே எக்ஸ்ப்ளோசிவ் growth தான் இருக்கு. நீங்க ரேண்டமா ஒரு 10 இன்ஜினியரிங் காலேஜ் எடுத்தீங்கன்னா அதுல 8 இன்ஜினியரிங் காலேஜ்ல பிடெக் இன் ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ் அண்ட் டேட்டா சயின்ஸ் அப்படிங்கிற கோர்ஸ் எல்லா காலேஜஸ்லயும் ஓப்பன் ஆயிடுச்சு. ஸோ அது எதை காட்டுது அப்படின்னா, இனி புயல வரப்போற காலங்கள் எந்த ஒரு டெக்னாலஜி இருந்தாலும் ஐஓடி, ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ், ஆர்டிஃபிஷியல் நியூரல் நெட்வொர்க்கிங், டேட்டா சயின்சஸ் இதை சுத்தி தான் வரப்போகுது அப்படிங்கிறத தான் காட்டப்போகுது. ஸோ ஐ வாண்டட் டு இன்டென்ஷனலி ஷோ திஸ் ஹிஸ்டாரிக்கல் வே which has characterized with 2 types of winters, AI winter 1, AI winter 2. So இதுதான் சிம்பிளர் அரேஞ்ச்மெண்ட் ஆஃப் அன் ஆர்டிஃபிஷியல் நியூரான். எப்படி இருக்கு, இன்புட்ஸ் எல்லாம் இட் ரேஞ்சஸ் ஃப்ரம் x1 x2 to n நம்பர் ஆஃப் இன்புட்ஸ் இருக்கும். அந்த ஒரு இன்புட்ஸ்க்கும் we assign weightage w1 w2 wn weightage. இங்க இந்த weighted sumங்கிறது வந்து you do the summation of that, from there you do an activation function, அதுல இருந்து you get the output. So this is how an artificial neuron looks like. சிக்னல்ஸ் எல்லாம் வெளியில இருந்து வரும். இதனாலதான் இந்த ஸ்ட்ரக்சரை வந்து நியூரான் அப்படின்னு சொல்றாங்க. இது ஒரு ஆர்டிபிஷியல் நியூரானா இருந்தாலும் பயாலஜிக்கல் நியூரான ஒத்து இருக்கிறதுனால they call with that same name. There is a final step of perceptual algorithm that would give rise the incredibly mysterious world of neural networks. The artificial neural network would train itself. இப்ப நான் சொன்னேன் இல்லையா, இந்த ஒரு ஸ்லைடு வந்தனாலதான் என்னால இந்த கொஸ்டினுக்கு ஆன்சர் பண்ண முடியல. வாட் வாஸ் சோ ரிமார்க்கபிள் அப்படின்னா, the remarkableness of artificial neuron is nothing but it can train itself based on its own results and fire better results in the future. So இது என்ன செய்யும்னா, ஆர்டிபிஷியல் நியூரல் நெட்வொர்க் ஏன் ரிமார்க்கபிள் அப்படின்னா, அதனுடைய ரிசல்ட்ஸை வச்சு இட் கேன் ட்ரெயின் இட் செல்ஃப். ப்ரீவியஸ் ஹிஸ்டரியை எடுத்துக்கிட்டு we have to train in multiple layers போட்டு ட்ரெயின் பண்ணோம்னா better results will be obtained in the future. That is the remarkable thing in the artificial neuron. இந்த நியூரல் நெட்வொர்க் இல்லைன்னா பெர்செப்ட்ரல் அல்காரிதம் ஏன் ரிமார்க்கபிளா இருக்கு அப்படின்னா, the artificial neuron cloud, a neuron could train itself based on its own results. அதனுடைய own results அடுத்தடுத்த லேயர்ல அது ட்ரெயின் பண்ணும்போது it will get finer and better results. In other words, it could learn by trial and error, just like a biological neuron. இதனாலதான் artificial neuron is very remarkable. Okay, this gives you a very most of the books or most of the illustrative examples, they give this example. இதுல பாத்தீங்கன்னா இந்த கோட் அகாடமி அப்படிங்கிற சைட்ல இருந்து எடுத்துருக்கேன். மோஸ்ட் ஆஃப் ஸ்லைட்ஸ் நான் எங்க இருந்து எடுத்தனோ அதனுடைய லிங்க்ஸ் வந்து கீழே கொடுத்துருக்கேன். At the end of the presentation, I will hand over the thing to for your better understanding. If you want to generate a neural network to distinguish between photos of cat and dog, what are all the inputs you have to take? So என்னென்ன லேயரிங்ல பண்ணணும், even though we try to predict the particular animal, there is a potential chances, நிறைய சான்சஸ் இருக்கு. ஏன்னா மீசான்னு வச்சேன்னா நாய்க்கும் மீசா இருக்கும், இங்கே மீசா இருக்கும். இயர்ஸ் பாத்தீங்கன்னா ரெண்டுக்குமே இயர்ஸ். ஸோ we need to go beyond. அதுல அப்புறம் என்ன பண்ணணும், அதனுடைய diameter of the skull, அப்புறம் ஃபேஸ், கலர்ஸ், ஸோ இது எல்லாத்தையுமே மாத்திட்டு டெக்ஸ்சர், இப்போ நாயோட டெக்ஸ்சர் எப்படி இருக்கும், பூனையோட டெக்ஸ்சர் எப்படி இருக்கும். ஸோ we have to give more attributes, நிறைய குணாதிசயங்களை உள்ளடக்கினா மட்டும்தான் இந்த சென்சரிங்ல you can get a correct output. Otherwise a cat has a potential chance to get misinterpreted as a dog, and vice versa. நாயை தவறுதலா பூனையா சொல்றதுக்கும் சான்சஸ் இருக்கு. So this is how that is what this is another exploded view of an artificial neuron. என்ன செய்றாங்க, the inputs x1, x2, x3 till x1 is given. Those inputs have been assigned weightages. You can see suffixes of w1j, w2j up to wnj. From there you get the summation transfer functions, and in that you have an net input, and in that you have a threshold in which an activation function is assigned to it. So this is the core component of ANN structures in the artificial neurons. Each neurons receives inputs from several neurons. You can see each neurons will get several inputs from other neurons, multiplies thence with the weights assigned. It is being multiplied with the weights, adds up and passes through one or more neurons. Some artificial neurons might apply an activation function. This is the activation function which is applied to the output before passing it to next variable. According to the criticality of the received signal, an activation function is applied to the output before passing into the next variable. So இந்த இடத்துல synapseன்ற ஒரு கான்செப்ட். ஓகே, இப்போ நம்ம பார்த்த ப்ரீவியஸ் இதுலாம் வந்து பாத்தீங்கன்னா இட்ஸ் ஜஸ்ட் ஒரு லேயர் தான் இருக்கு. When you have deep learning algorithms, multiple layers வேணும் அப்படின்னா we have a set of hidden layers. So where we have input is given in the left, you are expecting a well-defined output. If you are having a very deeper learning, that becomes mandatory to have hidden layers 1, 2, 3, 4, 5, 6. There are 6 hidden layers to have a well-defined output. அப்ப இது மாதிரி அதிகமான hidden layers இருந்ததுன்னா we call it as deep learning algorithms, and it automatically forms a bleeding edge of artificial intelligence. Yes. So இது வந்து textbook level, whereas project level என்ன மாதிரியான earlier we found only what is the distinguishing criteria of cat and dog. So now in practical project level ones, we need to identify how does a car look, how does a person look, how does an animal look. So இதெல்லாம் input இருந்ததுன்னா what will be the pixel levels? We have 3 hidden levels. First hidden level, second level hidden level, third hidden level. இப்போ input pixelsல இருந்து எப்படி இந்த ஜோனுக்கு நம்ம ரீச் ஆகுறது? There are several levels of hidden layers so that we do the deep learning, whereas the observed visible layer of input pixels will be interpreted as a car. Carna enna mariyana pixels are there. When you get a person, what sort of input pixel is being received? So enna mariyana hidden layers are being involved. You can see that the importance of deep learning in interpreting a car, a person and an animal. So அது இல்லாம பாத்தீங்கன்னா இது நம்ம ஃப்ரீக்வெண்டா எல்லாருமே நம்ம ஐஆர்சிபி சைட்ல
Sir, am I audible, sir? Sir, excuse me, sir.
Yes.
Sir, the participants are asking only to take in English, sir. Most of the participants couldn't be able to understand your Tamil, sir.
Yes.
Frequently asking. Thank you, sir. Thank you, sir.
Yeah. Yes. So this particular kind of multiple layered neural network makes us the algorithm designer to make into account that it has multiple hidden layers. Because in the earlier example we have seen just demarcating the differences between a cat and a dog, whereas both are animals. In this particular ground zero problem, like when you come to the exact scenario in the industry or in the executing place, you need to identify between car, person and animal. So you need to have a living being, non-living being and animals. That induces the algorithm designer to have multiple hidden layers. So these training artificial neural networks, this kind of image clicking, we have been using it for a long time. Like in a day-to-day life, we use a non-stick tawa without knowing the nanotechnology in the non-stick tawa. Similarly, whoever come across in booking a IRCTC ticket, they will be clicking several images. You may be wondered why they ask to book Tatkal. In that they give captchas. Captchas are nothing but same letters which is disoriented, distorted or little skewed. Why the letters in the captchas are little skewed? Because there are people who write algorithms to crack such programming and ticketing websites so that they write an algorithm in one shot they can book hundreds and hundreds of Tatkal tickets, which is practically possible when you can crack the particular website. So in order to avoid that, they wanted to have a captcha which cannot be cracked by a computer algorithm. So gradually the algorithm designers and the hackers, they can able to crack captchas also. Now the next level of thing is picking the signals, like click where the cars are going, click on the signals. How they vary from an algorithm to human being is, the moment you see such pictures, human being will tend to take a lag, some time lag will be there. And you may not suddenly you will not have any fast clicking of the algorithm pictures. You will take one by one, next way of, and then you are waiting. One or two things you may even miss. So that sort of error they are looking for, because humans are having the tendency to commit that missing of some small errors. So such kind of artificial networks, training the artificial networks is needed in both the sides. If you want to attack a particular website or you want to address the particular, read the image of the particular one, you need to address it in this form. Otherwise, you want to have the authenticity and the you want to retain the sovereignty of the website, you should create the one which cannot be cracked by the algorithms. Yes. So for that, these hidden layers, how many layers are being included in a potential system, makes you the quantum of the complexity of machine learning. So in machine learning, we have three types of main bifurcation. One is supervised learning, which is very structured and which have classified, which has its own diagnostics, customer retentions, identity fraud. And that has a regression model also. The other one is unsupervised model learning, in which you have a dimensionality reduction and clustering techniques. And the last one is this reinforcement learning. So these are all the different types of learning currently existing in this. So how does this neural networks makes you the works little easier? So it is all about how the parents teach the kids to identify the apples, identify the oranges in real life. For computers also, practice makes the perfect. So you need to train by giving the same inputs again and again and again, and you need to make the system to get trained so that you finally end up with, though you have multiple ambiguities in finding the dimension, color, flavor, fragrance of different fruits like apple, orange, pineapple. Our aim is to find an apple. So we need to train in such a way. The neural networks have been made in such a way to identify the exact fruit apple, which is red and which has bilateral symmetry and with the color of red. So in some cases, there is only one trait which will find out to be the demarcating character. In some cases, it is not sufficient. In that cases, like we need to go study about the texture. Texture becomes one attribute, color becomes another attribute, shape becomes another attribute, size becomes another attribute. Like when you want to distinguish between cat and dog, definitely size becomes different in the terms of cat and dog, in terms of differentiating. So such kind of including several traits, several characters, several attributes in the learning process is called as tweaking. Tweaks is nothing but fine adjustments or fine tuning, and adjustments are made to help each other neuron better to identify the data at every level. So texture, color, shape, size, everything has to be. So when you don't succeed it first time, what you do is nothing but you got to go for trial and error the next time, because we are already known with the existing expected answers. So we need to train the system. So this process is repeated over and over until the neural network is identifying apples and oranges. Increased accuracy is expected. Eventually, in 100% correct predictions, as per the neural network techniques, 85% is acceptable. So this is the first thing what you should know when you are working with neural networks. It's always not believed that 100% of the predictions will go right. When the success criteria or the accuracy rate is beyond our 85%, automatically it becomes acceptable. So till you get an apple, you keep on training the hidden layers. So now you can see several day-to-day, as I have given an example for tactile booking and how the CAPTCHA was used. Later on, CAPTCHA was advanced into clicking the signboards, clicking the car, clicking the signals in the pictures. It will have 8 mosaics of small pictures. Similarly, day-to-day users, what we come across in our day-to-day life, but we may not know the technology behind the service. What we are using is neural network. I have just used Google Translate, in which a French person is trying to translate into Arabic. He wanted to learn in the Arabic, so he has pasted the French text in the left window. Right side, it is automatically getting translated in his Arabic scripts. So that is the best example. This is all happening due to the neural network algorithms. The French language is automatically converted into Arabic scripts. So as we all know that every single cameras is activated with the touch sensors, some of them with the gesture sensors, some of them with the face ID sensors. Now I think iPhone 13 released, it has got scanning the retina. Inside your eye, there is one particular soft region, tissue region, that is retina. If you have the problem in the retinal correction, you go for a short sight concave lenses and long sight convex lenses for correcting the eye vision. So the retina is very, very distinguishable like our fingerprint. So now scanning retina has become the face ID for the latest iPhone Apple phones. The reason of usage of drastic amount of users of Apple phones is that platform is limited for the virus program hackers. So usual hackers, they try to go and attack Android platforms. The Apple has got a strong security systems. So these are all the potential applications which we use for handwrite recognition, image compression, traveling salesman problem, stock exchange prediction. It's a very big business which is happening. In the terms of stock exchange prediction is happening a very voluminous amount of information which you give on the like seasonal prediction, monsoon prediction, and if you have that budget, pre-budget and post-budget, what is the tendency of the BSE Sensex? How can be predicted? Though you have several algorithms like candlestick predictions, and you have several predictions existing. though we have that, but neural networks is very much complementing in predicting the stock exchange indices, whether it will fall, whether it will have a surging, when will bear will come, when the bull will come, image compression without the compromising of the accuracy like that. So this is a quite frequently used gadget in our day-to-day life. Alexa, Alexa, what is the weather? Alexa, I want to hear the old songs of Tamil. Alexa, tell me a joke. Alexa, how do you feel? Alexa, have you taken breakfast? Some sort of kind of interaction. So since we are getting addicted to gadgets, nowadays we need to, like we can go for a telephonic call, we can book a saloon, we can book for the next, you can get the information about the nearest movie theater, nearest gymming for your physical activities, nearest swimming pools, all the information you can get connected. So now, due to the over usage of addiction and to that, naturally with Alexa, cure my depression. Yeah, your nearby yoga centers, meditation centers, nearby psychiatric counselings, everything will be in the internet. So once you have a problem, it's always have two sides of the coin. You have merits as well as demerits. So this is about the biological interventions of how the artificial neural network has been intervened with the image processing technology to counteract the cancerous tissues in the breast. So this is about the breast cancer finding. Once you have taken a breast cancer diagnosed on a manual pattern using a digital image technique, those image patterns can be stored, and the stored ones can be given as comparing with the samples patient, the patient which has been taken as a sample. If you compare it with the existing cases, if the cyst is being matching with that, so it cannot be a concluding one, but it can give you a perfect, close to the nearest result, because we already have the existing atlas. They say it's an atlas or a historic informations which can be compared. So Cognizant is taking up applying the deep learning to transform the breast cancer diagnosis. So they are working with the deep learning algorithms to transform the breast cancer diagnosis. The diagnosis part is being done by that. So this is one such study for skin cancers. So as we are blessed to live in India, the temperate zones, we are having less amount of skin cancers. The other way, since our tobacco consumption is more, we are more prone to mouth cancers. And in India, since we get enormous sunlight, vitamin D3 is abundant in the sunlight. These kind of skin cancers are very, very minimal in Indian context. There are two types of developments. One is benign, which is not dangerous, and the other one is malignant. These are all the potential dangerous modifications. And there are three types of things in which an epidermal, melanocytic, small coloring pigment melanin, melanocytic lesions, dermoscopy. These are all the different methods of characterization. So once you have that, you characterize it with epidermal benign, epidermal malignant, melanocytic benign, and melanocytic malignant. Epidermal is outer skin. Melanocytic is the coloring pigment. Benign means it is not dangerous. Malignant means it's very, very critical, which is potentially it will become a cancerous cell. So such kind of benign, malignant, melanocytic, if you want to have a biological neural network, these kind of jargons you should be familiar of. It's a benign tumor, means it's not a potential dangerous tumor. It's a malignant tumor, so it is cancerous tumor. So like these kind of jargons you should hear. Now we are gradually getting into what is computer vision. These are all CCTV cameras which can have a vision which can distinguish between baggages, human beings. All the human beings you can even have a same color. Now current condition of pandemic demands the temperature profile also. You can isolate among the 50 people who is having the higher temperature than the average body temperature. So next one is the amount of pupil movement, and in computer vision with face recognition, they even go with whether the person is lying, how many times his heart is pumping, how much time in the eye he is winking. The facial recognition can be intervened with the forensic department also. Yes, I have intentionally introduced in the picture. If somebody is asked to see what are all the objects seen in the picture, we will start listing: grass, blanket, juice bottles, a mother, a father, a boy baby and a girl baby, a basket. If you list in this way, you are an artificial neuron. Whereas you say a family is come on a picnic, this is the human way of intervention. you can able to distinguish between the difference in the perception, because a computer will start interpreting object by object, but in a wholesome way, whereas a human being will perceive the picture as a total entity in a single way. You can say a family outing, a family going on a picnic. So this is how the perceiving of between a human brain and an artificial neuron is that. We are trying to make the artificial neuron, instead of going to see what are the objects, green grass, blankets, juice bottles, blank basket, father, mother, happy child, this kind of object by object, make the artificial neural network capable enough, when it sees the next time, automatically it will fasten up and say it is a picnic outing done by a family. So this is now gradually we are getting into self-driving cars. When you come across the concept of self-driving cars, it is not only needed to identify the pedestrians, it is also equally important to know the cyclist, the fellow car passengers, other obstacles, nearby signals, everything should be sensed. So it appears to be a very kind of clumsy as well as, but when it happens in the kind of schematic algorithms, these kind of driverless cars and their movements is quite possible. So even without traffic signals in certain places in Chennai and certain places in traffic Mumbai, we have been using such kind of traffic without having intelligence. But there are potential chances of having accidents. To avoid that, we should have sensors equipped with it will be giving awareness and alert towards the progressive vehicle, which is receding vehicle. That's all. So that is what this particular GIF gives you a clear output about how does the scanning comes with the augmented reality. When you have a driverless vehicle, it has to take a snap and it has to augment it. The opposite vehicle is a MUV, multi-utility vehicle. The adjacent vehicle traveling to me is a SUV, sports utility vehicle. Sports utility vehicle means what is the maximum length? It is 4 meter or sub 4 meter. What will be the time taken for crossing it besides me when it travels with my same speed? So these kind of algorithms should be involved for such kind of driverless car vision techniques. So this is about characterizing the pedestrians, the object class pedestrians 1, 2, 3, 4. How does the input image is being taken? The thermal profile, depth profile, object detection, intention predictions. So what is the risk level? What is the likeliness of the pedestrian to cross? Very risky, bit risky, attention and safe. If it is safe, the car will proceed. Because in European and international perspective, much respect is given for the pedestrian rather than the car driver. Here in Indian perspective, the car driver used to shout on the pedestrian. Have you told your relatives? Have you gone mad? Like that, they have the freedom or sort of psychological outburst on the pedestrians. Whereas in European context, the pedestrians were given more respect. If somebody is trying to cross on the zebra crossing, the car rider will stop, the car driver will stop and allow the pedestrian to pass, and then he will go. They never honk on human beings. They use honking horns against the animals. So this is how you can see the Tesla one, which has an augmented mapping. He is trying to go on a cruise mode, though he is sitting, is not touching the steering. So it is being given commands about the augmented take right, take left, all those Google Maps incorporated. Augmented reality is coming to the picture, where you need to have multiple convolute. We'll see a few slides about the convolute neural network. Yes, next slide is convolution. We can see the very famous Tesla logo in it. They are the leaders in the electrical cars because the minimum amount of time they have the maximum availability of the charge. So in this convolutional neural network, how does it differ from the normal conventional neural network? Convolution is nothing but in mathematical perspective there are two functions in which they combine together to form the third function. That is called convolution. So you can see how neural network, you can see how much inputs are given, summation, then you can augmented functions given. Whereas a normal one input level, which are hidden level, up to 8th level of hidden level, which is output level. So from here to here, you can just have a head-on comparison with artificial one and normal neural network. So the convolution I have told, when there is more than 2 operations in which it is being operated to get. So such convolutions, you can see the 2 detection of the texture and the image, it goes to the next one. You have the 2 feature maps going to the next third one. You have the 2 F maps. In the convolution, you have the subsampling. In between, you have intermittent F maps. Again, you have a subsampling, and when it is fully connected, you get an output. So whenever you have 2 operations, you end up with the third operation. It forms a conventional definition of convolutional neural network. Yes, it's followed by pooling up of the layer. How does it work? First layer will have 1000 nodes, and second will be reduced into 500. So there will be 1000 into 5000. It will have 500,000 connections. This also means the neural network will be focusing on so many features. That's what I told. For a single understanding, from 2 to 1, that means many to 1. You have more focusing on more features and end up with one distinguished defined feature. A pooling layer reduces the representation size by taking the input regions and selects the strongest feature. This speeds up the computation and makes the features detected clearer. This is very, because the convolutional neural network becomes the driving thing in the driverless car, because it needs to have the features which is having the clear amount of detection. So the features which is being detected by the driverless car should have the clear distinguishable features. So this is a very nice of how we go from many to few. This is the very nice GIF I found. If you teach several hundreds of words and several textbooks how convolutional algorithm is working, you may not be able to understand. If just following this GIF, how a particular 5×3 is converted into 3×3. So a 5×5 matrix is being converted into 3×3 matrix. This is the methodology of the algorithm behind that is called convoluted or convolved feature. Now we are stopping to the application part. Now we are seeing 1 or 2 slides about the advantages and the limits of neural networks. The main and vital advantage of neural network is it is non-linear. Usually, when you have a linear one, you can see the approach. The batch of learners, we have trees of knowledge which has from left to right, from start and finish. We know a linear path. There is no zigzag, chaotic way. Whereas when there is a non-linear path, start and finish is known, but our path is very zigzag and chaotic. So one advantage of neural network is that they are capable of learning in a non-linear way. So this is the one, because it has its own level of hidden layers which it can train itself, so that it becomes a non-linear way compared to the conventional linear way. This is the biggest advantage of neural network. So here when you have the facial recognition is requirement, what sort of facial recognition can be done? Creating a database. All our people have our own selfie camera. They will open the selfie camera and say, your face will be recognized as male, age 23. So for such augmented reality, the mobile has to have several thousands of frames inside, and it compares with the female image and the male image. If it is a male image, what will be the eyebrow questions? How does a male has? What is the mustache question if it is above a particular 18 years old? So it compares and gives you. So it needs a database, even from your mobile selfie camera, which augments your age and sex. We are knowingly using, without knowing that the hidden part is working with the neural networks in the mobile phone. So it has captured individual images if you want to track in a specific format. Annotate images. This is very, very important. Annotation means it is about the key data points, the distance between the eyes, width of the nose bridge, distance between the upper lip and the nose. There are dozens of measurements which gives you the unique characters of each person. And capture of new images. If you want to capture the new images, whether the photographs or video content, they go through the measurement process again, marking the key points of the image. So this particular facial one is the actual one, what you are going to see in the next few slides in the case study. This one I wanted to show. If this is being given for a person to learn, they will say it's a bear family, just come for a picnic. But if you give it to a computer, neural network will never understand this because it's an animated one. It's never come across such, it's a highly unique one. All the characters are not very familiar for that. For that, we need to see like the sun will never be assumed as animated, having hand in hand with clouds. It's a very super it's a kind of unbelievable or some sort of euphoric state or sort of some imaginative state. So such kind of things cannot be understood by computers. Such kind of, these are all called the limitations of computer vision. If you try to crack the image by the use of a computer algorithm, the computer may not be having a previous historic information where an animal set will go for a picnic. So this is how the limitation of computer vision and neural network. So we need to train it for such kind of animated. For case study, we need to cite. We have to design it. So this is the neural network limitations what you have. Unlike human brain, it can learn, do things with very few examples. It needs thousands and millions of examples. That's what I have putting in the previous slide. Such kind of examples, if you incorporate, it will crack. Otherwise, it will be in a struggle. So neural networks are bad at generalizing. It cannot have a, see, even for the example, if you give a cat, it have a potential chance to detect a dog. So it will not be able to detect. So generalized, it cannot be. And neural networks are opaque, means it is treated as a black box. You have some kind of information, you don't know about what is the information is all about, it is called black box. In airplane, the black box is having a very good understanding. Like if after an accident, you go and find a black box, the final reason for the accident will be recorded on the black box. Whereas in this perspective, black box means you have a set of information. You actually don't know what is the need or what is the implication from the set of information. That kind of box is called black box. If you don't have proper information with proper logic behind the decision, automatically there is a potential chance of having black boxes using neural network. This is a last case study. I tried to rush up. This one is a touchless display, which is being, you can see just exactly 1 year before today. It has got an award of Deep Learning Superhero Challenge. It was by Anand PV. He works in HCL. And this touchless display interface is the need of the hour because since we are facing this pandemic threat, whenever we touch certain objects or certain gadgets, we always have the threat whether it should be sanitized, what sort of effectiveness is there in the sanitization, what sort of infection chances is there in using the kiosk. Kiosk is like, as in India, some kiosks are coming up. For us, kiosk means only ATM. In airports and some other places, you get money, you have to put some coins to get Pepsi, canned drinks, or water bottles. They are such a kiosk. They call it as internet kiosk. Any public accessible service centers are called kiosks. So such potential threats are there in the case of viral infection loads. So such kind of touchless display interfaces has created a very abundant interest for the technology updaters. So I find these another few slides to have a clear idea about how does this touchless display interfaces have an impact in current day systems. So he has having incorporated the algorithms 4 control modes. One is a no control mode. Another is a gaze angle control. Gaze angle is nothing but an angle of vision. Gaze means a short sight. At some point of time, you are giving a gaze. And head pose control. How do you tilt the head? What is the head nodding? And this kind of head pose. And last one is sound controls. According to the 4 modes of controls, they are using it. So the gesture and sound negation stand off when there is no. Mouse moves along with the angle of the gaze faster. Mouse moves with the change in head orientation. Eye gaze and mouse move are synchronized in the faster way. The same kind, the mouse and the head orientation in the slower pace. This is how it gets varied. If you change the pose of the head, the mouse moves in the slower orientation. The same time, if the gaze is changed, it moves in the faster mode. And the last one is sound control. So the mouse slides 4 direction types based upon the user utterance. What is the word being uttered, or amount of decibels and sound? Accordingly, the mouse slides in 4 directions. Yes. So where do we have the application of this particular touchless interface? Means we have lots of potential places like public kiosk and ATMs, airport check-in, baggage scanning, government e-governance, retail, product catalog, healthcare appointment. Now we have 24/7. Practo apps are there. IoT platforms are there. School attendance. In our office, we have BARS, biometric attendance recording systems, where you have earlier we used to keep our forms In some places, the retina scan in attendance is still existing in most secure places in our atomic energy establishments, corporate registrations, events, the passes, and where the business have the kiosk, better service delivery, touch-free interaction to all public devices become imperative. Touch-free interaction is now imperative, means it becomes mandatory to mitigate the spread of ubiquitous coronavirus. This is how I told, how does they control the gaze? So this is actually head position and gaze monitoring. Yes, you can see the facial landmarks for having, again, previously I'm seeing how that supervision, computer vision in driverless cars are there. CNN means convolute neural networking. First you have to index the image positions, 35 facial landmarks. So nose bridge, eyebrows, cheeks, chin, lip, upper lip, lower lip, because every single feature will have its own implication in terms of pixel capturing. I have some two or three slides which give the importance of eye blinking and eye winking, and the other one is lip movement. Also, I have 1 or 2 slides. You can see that. You can see that calibration is done on mode with this having no control. You can see this is a very wonderful GIF. If you close this eye, automatically the pixel increase. If it is open, it is less, 127. If it closes, it is 142. If it is open, it is less. Pixels are less. When it is closed, see 127. When it is closed, the pixels are getting more. So number of white pixels is suddenly increased when the eyes are open. White pixels should be more because in open eye, white pixels are there. When it is closed, automatically what happens? The white pixels will drop and red pixels will increase because of the skin color. So this is how they map the blinking with respect to the time, right eye and left eye. So in that way, they can easily see whether a robot or some other vision system is seeing or a human being is seeing. So the sigmoid curve fitting left to right wink, you can see that. How does they wink? Once the wink is there, it is being recorded simultaneously. If he is winking, you see he is winking the right eye. Winking, yes. When it is winking, it is immediately responding. Undoubtedly, this project being done by is winking the left eye now. Has won a very nice award in the because of the need of a touchless interface, which is the current day requirement in this pandemic conditions. He is alternately winking the left eye and right eye. You can see how he indexes the dimensional positions in the open eye and the winked eye. In winked eye, there is a drop in a particular one. So this is for the lip arrangement of facial landmarks, 9, 10, 11. MAR is nothing but multivariate adaptive regression. This is a very important thing. When you have multivariates, you have several variates in which adaptive regression is there. This one example which is using the MARS, multivariate adaptive regression system, and is well suited for high dimensional problems, a large number of inputs. It can be used generalization of stepwise linear regression. So this is about other gesture and other actions. If you yawn, it will be a left click. If it will be looking up, right click, right wing. Left wing is unassigned, smile is unassigned, vocal up, move mouse 10, 13. These are all the actions corresponding to the type of gesture done by the. So this was the conclusion of the case study, what I have taken it. It was an open window to handle. He used Python for this all programming. If you go to the site, all this open source coding is quite available. You can learn it. Gaze control is ideal for a big screen. Head pose is suited for laptop screen. There is 2 controls for gaze control. By seeing, it is suited for a big screen approach, whereas a head pose control is very much suited for a laptop screen. Either way, sound control can be helpful to accept the custom form entries, the vocal commands. Gesture action mapping can also be modified. So sound control is trade-off between both gaze control and head pose. He has tried to find the implications of gaze control, head pose, and sound control with their touchless interface. So now we have come to the conclusion of our entire talk. So ANN is good for all small problems or networks, but ANN is little challenging for bigger networks. Bigger network is becoming challenging because we need more training time and hard to find good network configurations. Little harder. We need to do lot of trial and error and lot of iterations. That is what this bigger problems they choose for PhD like research strategies, and they are good at publishing things. We need to do first a lot of experimental things to train the network. We cannot go by prediction with very less amount of data, then your amount of error will be more. So ANN is a good method for solving hard computational problems, which involves lots of numerical and analytical formulas and predictions. So more research on human brain could be helpful in constructing better ANN. So now you should understand what is the need of interfacial or interdepartmental research. If you want to really come with out-of-box ideas in ANN, you need to do a lot of biological research to see the pros and cons and the length and breadth of the usability of a human brain, what extent people have used it. So then you try to mimic the same amount of capability with the existing neural networks, and you start training that with multiple layers with machine learning, multiple hidden layers, and you match up it. And the final conclusion I intentionally added in the Tamil Nadu perspective. I have come across lots of IITs now come up with part-time online courses, especially IIT Chennai has come with online courses. It was BSc Data Sciences and Analytics. Anyone who was already doing an UG is also eligible, who was working also eligible. It has 2-tier entrance program. It's a very strictly conducted program. It's an online program. It has got very nice syllabus. You have time to go to IIT Chennai, IIT Madras site. Bharadas University has started running such online courses. IIT Calicut, some PG diploma in data science. Now all the IITs have started emerging, conducting these kind of online courses, especially emphasizing on data sciences and programming basics like open source programming like Python. The other one is like how they handle artificial neural network and artificial intelligence and machine learning. That is also more emerging kind of data, more emerging kind of department. So with this, I thank the organizers for giving me an opportunity to present this small talk as an inaugural address, and I wish the participants to have an interesting sessions in the forthcoming days. Keep on make a note of the interesting potential areas where you can convey this to your students or your research scholars, or you yourself may be research scholars who can take up certain ideas to add up certain value to your research, and also which will make easier for your publication to get accepted in minimum amount of time. I wish you all the best for the participants for the rest of the course. I thank the management, Chodi, professors for giving me an opportunity to deliver the talk in this wonderful occasions. Thank you.